Hey there, I'm Teacher Rommel. I will be your science teacher for today. Welcome to our online video tutorial. Before we start, make sure that you have the following materials with you: your book, notebook, pen, and a highlighter. Have you ever felt sick while riding a ride in a carnival? You may have had motion sickness. Some people think that motion sickness is a problem related to stomach. However, motion sickness happens when a person's sense of balance is thrown off. Balance is controlled by the inner ear. Sometimes, the inner ear and the eyes process riding in something, such as car or airplane, or even in carnival rides, in different ways. Motion sickness can cause people to get pale, to get sweaty, or to vomit. People who experience motion sickness can do the following. If they are riding a car, they could just stop for a while. Next, people who suffer from motion sickness while riding in cars can often find relief by using the horizon in front of them as a reference point. They could also take medicine to feel better, or they could just simply close their eyes. Motion sickness has something to do with our lesson for today, which is all about motion. The objectives of this lesson are as follows. First, to define motion, relative motion, point of reference, and force. Then, compare mass and weight. Third, investigate how an object's mass affects the amount of the force needed to move it. Then finally, understand how Earth's gravity affects objects. Let's take a look at the picture here. What movement do these cars can make? Definitely, there are three possible movements they can make. They can move in a straight line, they can move in a curved path, or even they can rotate if they wish. All of these movements refer to us as motion. Motion is a change in the position of the object. Position here means the location of the object. As long as the object changes its position or location, we can say that it is in motion. I want you to meet Chino. He is a superstar kid who is a genius in playing a drum. Do you think there is a motion created when Chino plays the drum? Great! Yes, there is. Chino itself doesn't move, but the particles of the drum create back and forth movement, which we call vibration. Earth, too, is in motion. It revolves around the sun 365 days. But where can we compare its motion? Awesome answer! We could compare it to the motion of a runner on a track. Just like a runner, Earth follows elliptical orbit, which means not perfectly rounded. You may have experienced when you are inside a car which is not moving and the other car moved. You felt that your car is moving too. But when you go out, the other car has actually moved and yours is not in motion. This has something to do with the term relative motion. Relative motion is the change in one object's position compared with another object's position. The word relative can be associated to a family member. Relatives are connected to each other because they belong to the same family. Relative here is used to describe how the motions of two or more objects are connected. To understand this concept better, let's take the following example. In this picture, the bikers are moving if you are going to compare them to the things they are passing by. In the same way, if you stop and observe the bikers moving away from you can say that they are in motion. But let us say the bikers on the picture move at the same speed and the biker at the back uses only the bikers in front as a reference. What might you conclude from this? Absolutely correct. The biker at the back may not be able to tell whether he is moving. This is because the reference he used, which are bikers in front of him, is at the same speed. Let us see if you learn the concept of relative motion. Those two boys in the picture are seated on the boat and rowing in. Can you say that those boys are moving compared to a boat? Definitely not. They are not moving because the distance between the boys and the boat stays the same. But if we compare the boat of the two boys to the other boy on the other boat, can we say the boat is moving? Exactly. The boat is moving because their distance changes as they row. Therefore, there is a change in their position or location. Look at those children on the water slide. How do you know if a person on the water moves? There are things to consider to say that the person is moving. First, you look at the changing position of a person in the water. Second, you compare the person's changing positions with the fixed position of the slide. And third, use the relative motion of the objects around you to decide what is moving and what is not. Let us now study the two confusing but important terms related to motion: the reference point and frame of reference. And let's first define them. Reference point is defined as a place or object used to determine if an object is in motion. An example of this is if you are 2 meters from the doorway outside the train, then your reference point is the doorway. This defines your position outside the train. Notice that you need a reference point, which is the doorway, and a direction, which is outside, to define your position. Frame of reference is a way to describe the motion of an object by comparing the moving object to an object that is in fixed position. For example, a girl is standing still inside a train as it pulls out of a train station. If you are standing on the platform watching the train move from left to right, to you, it looks like as if the girl inside is moving from left to right. Because relative to where you are standing, which is the platform, she is moving. According to the girl and her frame of reference, which is the train, she is not moving. Seems confusing, huh? Okay, let's make it simple. In reference point, we are talking about a location with a given direction. Usually, we use a fixed object here. But in frame of reference, we are talking about two reference points, which are fixed object and moving object. Objects around us move or stop because of force. Let us now study what force is. Force is defined as any push or pull. Force can affect the objects around us, and there are 5 ways in which it could affect the object. First, force can make an object move in the direction of the force. Second, force can make a moving object move faster. Third, force can slow down the object. Fourth, force can stop the moving object. And lastly, force can change the direction of moving object. Look at this picture of a boy playing marbles. This is an example of a contact force. A contact force is a force that must have a contact to an object to affect it. A marble on a level surface will not move until you hit it with your finger or another object. When your finger collides with the marble, it transfers energy from your finger to the marble to make it move. The collision of your finger and the marble also transfers some energy to the surrounding air, making a sound that you hear. Force can change both the position and motion of the object. The size of the change depends on the strength of the push or a pull. For example, the harder you push a swing, the higher and the faster it will move. Look at this illustration. Notice the dogs pulling on the rubber toy. They are pulling in opposite directions, but with the same amount of force. As long as they pull with forces that are the same size, the forces are balanced, and the toy will not move. If one dog pulls with more force, the forces will be unbalanced. The toy will move toward the dog pulling with a greater force. This illustration shows that all forces have size and direction. The two illustrations here shows different types of force. Which do you think is the picture that shows balance force? Great job! The first one. Balance force are forces acting on opposite direction which are equal. Objects here will not move. On the other hand, unbalanced force, which is illustrated in illustration number 2, are forces acting in opposite direction which are not equal. Objects under here will actually move. When you ride a bike, you push the pedals. If you push harder, the bike goes faster. When you turn the handlebars, the bike changes direction. Pedaling and turning change the bike's motion. This example shows that force causes a change in motion in an object. But we have to remember the amount of force acting on an object affects how the object changes speed, direction, or both. A moving object changes its motion only when a force acts on it. If balanced forces are applied to a moving object, it will keep moving at the same speed and in the same direction. The moving object will not slow, speed up, or turn until the forces acting on it become balanced. An example is when you continue to pedal your bike with the same force. The bike will continue to move at the same speed because the same force is acting on it. If the moving bike collides with another object, the bike will slow down or stop. The contact forces from the collision transfer energy and change the bike's motion. Balanced forces that are in opposite directions cancel each other. For example, if you apply the same force to the brake and pedal at the same time, the motion of the bike will not change. The force and the mass are factors that affect the motion of the object. Let's try to study this picture and answer this question. How will the force needed be changed if we take one pumpkin out of a wagon? Alright, you're correct. Less force will be needed. Remember, more force is needed to change the motion of an object with more mass. Therefore, the greater the mass, the greater the force we have to apply to move an object. The picture here shows apples that are falling on the ground. What do you think pulls the apples down? You're correct. It's because of the gravity. Gravity is defined as the force that pulls all the objects toward each other. We have to remember that objects pull on Earth too. It's just that their forces are not noticeable since these objects are too small if we are going to compare them to the size of the Earth. Let us now compare the effect of gravity in these two pictures. In which picture is the force of gravity weaker? Is it between Earth and a train or Earth and a satellite? You're right. The force of gravity is weaker between Earth and a satellite because there is more distance between the satellite and Earth. We always have to remember that the force of gravity increases as objects increase in mass and objects get closer to each other. Sometimes we use the word mass and weight as if they are the same words, but actually they are not. Mass is defined as measures of how much matter is in an object, while weight is defined as measures of how strong the force of gravity is in an object. How can we explain this? Let's use an example. For example, the astronaut lives on Earth with a weight of 48 kilos. But when he reached the moon, his weight changed to 8 kilos. This is because the gravity of the moon is lesser than the Earth, since it is smaller in size as compared to our planet. But the astronaut's mass will stay the same in any place. This only shows that mass does not change wherever you go, but weight changes. Remember, mass does not change while weight changes. Aha! I got it now! This is the reason why my science teacher told me that if I want to easily lose my weight, I have to go to the moon. I thought he is being sarcastic, but now it made sense to me. Before we end this lesson, let us wrap up what we have learned. First, we have learned that motion is a change in position of the object. We also have studied the relative motion. We've said that it is the change in one object's position compared with another object's position. Also, we've talked about reference point, and we've said it is a place or object used to determine if an object is in motion. Likewise, we also learn about frame of reference, and we define it as a way to describe the motion of an object by comparing the moving object to an object that is in fixed position. Next, we also talked about that force can affect the object in different ways. It can make the objects move, slow down, move faster, stop, and change their direction. Lastly, we differentiate mass and weight. That's all for this lesson. For additional information and homeworks, don't forget to log into your Person Realize account. See you next time. Bye!